Yeah, good afternoon, everyone. Can you hear me?
Yes.
Okay. So give me a second. Okay, let's start this lecture 8 today. So as I said to you, we are in the chapter number 3. We already finished chapter 1 and 2. So hope you are okay with that. If you have any clarification or anything to ask also, you can contact me. Okay. So this is about the chapter number 1 and chapter number 2. So we are in the chapter number 3 of interpolations. Here we have to study forward, backward difference method, as well as one more method, Lagrangian interpolation, and then extrapolation, inverse interpolation, as well as some error interpolations. Okay. So in that, so in this thing we have seen already in our last lecture for the interpolation, what is the definition for the interpolation problems, and as well as how to make the interpolation polynomial, as well as some theorems, one theorem. Okay, so I'm going to begin from the interpolation methods. Okay, so we have started something there, but anyway, I have sent you the module as well, so you can go through and let's understand first of all here. Okay, so in the interpolation method, I have divided some what is for the equal distance, what is for non-equal distance, and things. Okay, in that sense, for the equals equal interval of x, we are going to study about the forward differences. Okay, and non-equal unequal one, we can study the other method. Okay, so we are making this one a little bit shrunken because of the course content. Okay, so in the equal distances, forward difference in the sense we already have also seen in our chapter 2 as well. So the same things coming here, but let's see how we can solve as an interpolation. Okay, so if f is a function from x into y in the domain a comma v such that y we are taking as a function of x. For each value of x in the given interval, we can find the y putting the x values. Okay. The value of y can be determined just by substitutions. Okay. So when you substitute the x values, we can find the y's. Even though if the function f is not known, okay, they are giving x and y only. They didn't give you the fx. Okay. So in that sense, the value of y can be obtained when a set of values of x and fx are given. This method to find out such values is based on the principle is we called as a finite difference. So where we have to take the function is a continuous. Okay. So let's see the there are two methods as we have seen already under the forward difference. One is the Newton's forward difference method. Again, other one is Newton's backward difference method. So let's go through first of all that method, and then we can see one of the modified method as well on this. Okay. So I have sent you this module, so I'm going a little faster because I need to do the examples. Okay. Okay. So you don't need to write this one. I have sent you the notes. So whatever note there, only you have to write or spend time here. Okay. So let h as I taken, h is the increment. I mean, it means the increment in the sense, what is that means? So we are taking our h as a equal, no? Equal. So equidistance. That means for example, if I values of x are 5, 10, 15, 6, 20. So we are taking all the intervals between the values of x are same. So that's what we are taking as a h, isn't it? So x, the next point will be x plus h. The other point will be x plus. Can you fill this one? So for example, if you are taking one of the interval, we are starting here. My x1 point, let's say this is my x0 point. X1 point, the interval will be h. The line distance between these two value will be. So therefore, x1 I also can written as in terms of x0 plus h, isn't it? So what about the x2 in terms of not x1, x0? So how you can calculate each values in terms of x0? Yes, good. So it means 2 times h, isn't it? So you can take h plus h. So x0 is 2h distance from x2. So similarly it goes, okay? So since we are taking the equal distance, so h will be the increment of equal increments, okay? H is an increment given in the independent variable of y. So our function will be y is equal to fx. The first forward difference, as we've seen earlier, like delta y naught, which is equal to what? For example, if I say yn, delta yn, what will be this one? Yes, good. Everyone correct answers. So what is the forward difference? Forward difference, we use the delta, isn't it? For the backward, we use the nebula. Okay. For the delta yn is equal to what? Delta yn is equal to, can you fill this space? Can I get some answers? What is delta yn? How we can find the forward differences in terms of y? I'm expecting some answers. Yes, only 1, 2, 3. Okay, good. So we know forwarding goes from, it goes the y value, let's say y0, y1, y2. So it is forwarding, isn't it? So if it is yn, we take the difference between the adjacent y values from the, it means forward. So yn plus 1. If it is starting yn, you have to start with n plus 1. Then you have to take out that yn. Okay, this is what the definition we have seen in our chapter number 2. Similar way, if y is equal to fx, okay, what is y of, yes, let's say next y. So for example, let's say yx, and the increment will be the next point. Let's say this is yn is equal to fx. What about the yn plus 1? So as I said to you, this is x0, this is x1, this is x2. So this is my fx0, isn't it? This is my fx in terms of x1, which is equal to, you already told me that x1 will be x0 plus h. So this value will be x0 plus h, isn't it? Similarly, this one will be, so if I take this one only x, so this will be x. We don't need to put the x0, okay? So f of x is a value of x. In the point of x, we have the y is equal to fx. In the f1, the next point, let's say, this is my, let's say, nth point. This is my n plus 1 point, let's say, okay? So nth point, y is equal to fx. So next point will be, the end, xn will be x plus h value, isn't it? The increment will be h. So on that point, the functional value will be f of x plus h. So they are taking the definition in terms of fx. Okay. Therefore, delta of fx is equal to, so same thing. See, if it is yn, we have to subtract yn. Likewise, fx minus fx, where we are subtracting from the earliest point. That means forwarding. So f of x plus h. So you have to know how to, distinguish these values. Both are equal. Okay. For example, delta yn, we say yn plus 1 minus yn. Similarly, if you use the fx form, delta fx, I'm using for the fn, I'm using fx. So what is the next point will be f of x plus h. So x value is increment by 1 and then f of x. Okay, so both are equal way of representation. Okay. Similarly, what about the second difference? Second difference will be delta squared fx. Let's keep now fx. Okay, so delta squared fx means we are taking delta of delta fx. So as you can see in our table of forward difference table, so we are taking this one. Let's say this is x, this is y, this is my delta, this is my delta square, this is my delta cube. So in this, we between these y values different, we are putting here, okay, delta y. Let's say if it is y node, this is y1, this will be my delta y node. Then if you want this part, you have to take this difference now. So in that sense, they are taking, so in the representation, they say delta of delta fx. Okay. So we know delta, what is fx? Delta fx is already there now. So we are substituting this here. Okay. F of x plus h minus f of x. Okay. Then we are cancelling the bracket. So we have to give here and here. Okay. Delta f of x plus h minus delta f of x. Okay. That's how they have derived this one. So this is our second forward difference. This is our first one. Okay. Similarly, we can find higher orders, third order, fourth order, fifth order. We can find one general order, general nth order as well. For example, if it is delta Q, so delta and delta squared, isn't it? So delta times of this one. So delta times delta into delta squared fx plus h minus delta squared fx. Okay. So you can check this like this similar way. Okay. So we don't need to go further. So dot dot dot. It goes, this is our general nth order forward difference. Okay. Forward difference of fx. So delta n f of x will come as delta n minus 1. So 1, see here also this is one term. So there is no 0 terms. Similarly, 2 terms in our equation, we have 1 term in this side. Okay, so if you are taking n term here, 1 less term, no. So similarly, we can find from here. So delta n minus 1 terms of fx plus h minus delta n minus 1 of fx. So this is our general order. Okay. So we can use our forward difference table to answer our question. Okay. So no need to, anyway, we had to know these things. Okay. So let's use our forward difference table for our calculations. Okay. Let's do some example on it. Okay. So I also sent you the homework quiz number 5 for this chapter number 3. Okay. So you can try all the questions. I will do some. Okay. So first questions under this. So first 2 questions for this section. Two questions. So the question is, so you can go through the question. Construct the forward difference table. So if they ask you to construct the difference table to compute, you can also use that one. Otherwise also you can use. And point out the values of something. Okay. So first of all, we have to create one table, isn't it? Forward difference table. So this is our x value, y value, and then we can make delta, then on delta y. Okay. This is one delta squared y, delta cube y. So we don't know until where it goes. So let's keep like this. Let's have some spaces. Okay. So our, equal distance of x values are 5, 10, 15, 20, 25, so 30. So there is no use for this one. Only thing is you have to see the increments are same, as well as using this x only, they have found the y. Okay. Anyway, they have give you some values, so we can use it. Okay. We don't need to worry about what is fx. Okay. So they have found something. So in some cases, they will give you f of x. So you have to first of all find the y. Okay. So there are some, let's say 9962 and 9848, 9659, 9397. So I think same question I also sent you in the chapter 2 as well. So no problem. Okay, delta y. Can you find these answers? So how to find the delta y? You have to take the forward one. So from this value to minus this value. Okay. So you have to take the later value minus now value. So can you answer me these questions? I mean these values, so I can continue. So everyone can work. So I'm expecting everyone to answer me. Okay. So then only we can. So what is that? 9848 minus 9962. So no problem. It is like reducing, isn't it? So anyway, we can find you can use the calculators. No need to do the manually. Okay, I got one answer. Thank you. 114. Okay. Next one. What about others? 189. Next one. So you have to answer me. I'm not going to give you these answers. I will show the method, but I need your answers. Okay, good. 262. How about this one? These two. So don't worry about the negative signs and all. Okay, it comes. No problem. 334. Okay, good. What about this one? Is that minus 40? Okay. So minus 40? Yeah, 43. Okay. Okay, good. So let's go to the second difference. So what you have to do is from delta y terms forwarding. Okay. So this term to minus this term. So can you find these answers? Yeah, good. Minus. So 75 or 78? Which answer is correct? Okay, 75. Okay, what about this one? Okay. Next one. All right. One more. Okay, good. Okay, let's go back to this one. So you can see the differences are reducing, isn't it? So our work is coming very easy. Okay, 2. Okay, this one. 1. This one. 2 again. So 2 or 3. Yeah, 3. Sorry. Okay, then we can go for delta 4y also. So we need to go until we are getting the common element or shrinking to 1. Okay, last value. So what about 1 minus 2? So here you have to take these two difference. So this will be minus 1. Yes, this one 2, no? Yes. So we can also go for y5 as well, because that is the last point, isn't it? So it will be 3, isn't it? Okay. So this is our table values of for the forward difference. So the question is, construct the forward difference table for the given data and then point out the values of delta squared y10. So we have to know which values for which things. Okay. So they are asking you to find delta squared y10, isn't it? So we know this will be yeah, this will be 0. So let's say index value 0, 1, 2, this will be 3, this will be 4, this will be 5. Okay. So this will be y0, y1, y2, y3, y4. I'm just putting this end value to find out which value we are in. Okay. So this will be, so you can use after writing in the exam also, you use these value in a write like with a pen. Okay. Then use the pencil to find out which where you are. Okay. So it won't be like a mess like mine. Okay. So you can use a different, I mean, yeah, I can also use. Okay. So let's use any other colors. Okay. So this is delta, sorry, y0, and this will be delta y0. This will be delta y1. Okay, delta y2, delta y3, delta y4. Okay, then this value will be delta squared y0, isn't it? Similarly, this one delta squared y1. So my 10 will be, the index value is 1. So this will be my answer. See, very easy, no? Minus 73 is the answer. Is that correct? Correct me if I'm wrong. Okay. Okay. What else? They also asked a question. Delta cube, sorry, y5 15, isn't it? What is this one? Again, delta 5 y5. Okay. So you can see, okay, delta cube y15. So this I know, this is my delta cube y0, delta cube y1, delta cube y2. So I know my 15 index will be 2. So this will be my answer now. So this will be the answer. So my answer will be 3. So you can use the pencil or anything to, work through this. Okay. And then y4, 5. Sorry, y4, 5 means, so fifth, x value 5, index will be 0. So this will be my delta 4 y0, isn't it? Delta 4 y1. So this is what I am expecting. Okay. So this is. So is that my answers are correct? Check yourself. So this indexing way is easy for you. Or otherwise you have to put, y5, y10, y15 like that. Okay. So this is somewhat easy. So first of all, put your values in nicely with a pen, and then you can use other pen, other color or pencil to work through this to find out which answer we are expecting. Okay. So this is the answer for the question number 1, which is in the homework quiz 5. Okay, you can go through the second question as well. They didn't give you the table of content like x value, y value, like that. They have given you x values 0, 1, 2, 3, 4, 5, something like that. And then they have given a function y is equal to f of x, some function, okay? So you have to, calculate it y values and then make the table and then find your answer, okay? So only thing is you have to find this y value using the function has given, okay? So that's just a simple thing. So I hope you can do that. Okay. The question is find the value of y at x equal to 6 by extending the table and verify that the value is obtained. So what is they are asking is, okay, so I'll erase this window, okay. So after you, according to the x and y, okay, y of fx, you can find some answers now. Then you find delta, delta square, delta cube, anything what you can find, how much you can find, okay. Then they have given you only x equal to 5, but they are asking you to find the 6, okay. So the thing is, so what you can do is you have to yeah, give me a second. Okay, so you can go in this example, you can see you can go up to delta 3. After delta 4 everything will be 0, okay. So we can't go to the delta 4, you have to go until delta 3. So in the time of I'm explaining, you can make the table as well. And then we are getting the third differences. For example, let's say I have the 666 something. Okay, this will be the answer for the third column. I mean delta 3. And then so from that you can come back here. Okay, y6, I mean x6 value. So how? From delta squared y4, okay, I mean delta cube y3, you can find this delta 3 by 3, you can go for delta squared by 4 minus delta squared by 3, okay. So and then from that you will find some answer for the delta cube by by 4, delta squared by 4, okay. So from this you will find this answer. And then so delta squared by 4, which can be equal to y5 minus y4, no. And then from this we know y4, we know this one. So from that you can find the delta, this delta, okay. You can find the delta y5. So you can't use the table for these things. You have to calculate with the steps how you have found, okay. So I'm giving the steps, I'm not giving the answer, okay. So only thing is we can go up to here. So but with the this equation delta cube y3, this is okay now. Delta square y4 minus delta square y3. So from this you know this one, you know this one, so you can find this one. This minus this. Oh sorry, the minus, so it go here. So plus, okay. So our meeting will be finished 10 minutes, okay. So you find the delta square y4 is what? And then delta square y4 is equal to delta y5 minus delta y4, okay. So from this you know delta squared by 4, you know delta delta y4, and then you can find this one, okay. So you can take this side and you can find this value. And then y6 value is equal to what? Delta y6 value will be y5, no? Yeah, y5 will be y6 minus y5. Okay, you know this one, you know this one. So from this you can find the y6. So you have to use the steps. Okay. So if you find, check the answer. Y6 should be 241. This will be the answer. So I'll give you the answer. You have to do the steps. Okay. So that is the question of number 2. What we have in quiz means? I have sent the quiz in the group. Is that you asking? I also send the notes and the quiz in our group. Okay, check it. Okay, is that fine? So you do it yourself and see whether so use these steps to find out. Okay, so that's all the things. So let's continue our next method. So our meeting will be finished in 10 minutes. So sorry, it's at both our notes. Okay, give me a second, I will send. Okay, sorry about that. Okay, I will send up. Okay, now I'm sending. Okay, so check the group. Is that okay now? Yes. Okay. So I told you the answer. You just try yourself. Okay. So let's continue our notes in. Okay, I think we have 5 minutes, so we can do that. So this is all about the finite forward difference. Okay. So let's go back backward one. So that is also we have explained in our chapter 2 as well. Okay. So similar thing. Okay. So here also if you take the h as the increment. Okay. So in the backward increment and given the independent variable of function fx, then the backward difference of fx can be written as, here we use the nebula. Okay. So in that nebula we what is the sorry. So nebula of yn is equal to what? In the backward sense. What is the nebula yn? Can you answer me? So in the forward, we have taken delta y naught to y1. Then we have to take y naught, isn't it? So one term minus the same term. So this one is good. So nebula yn it is equal to same yn minus the earlier one. Okay. So in that sense, they have defined this one also. So I don't need to spend time here. Same way of forwarding. Here they have used for the yn, they use the fx. So fx, nebula fx equal to fx minus one term less than that. So fx minus h. Okay. So here we have taken, if it is x naught, then x1 will be x naught plus h. Okay. So in the backward, we are going this way. Okay. Forward, we are coming this way. So it is this one. Let's say this is my x, then this will be x minus h, and the other one will be x minus 2h. It's go in the from the down to the up. Okay, the other way. So this one will be forwarding. This one will be the backwarding. That's what the name comes. Okay. Again, the nebula squared fx equal to nebula times nebula fx, which is equal to nebula of, so you can substitute this one here. So nebula times fx minus nebula times fx minus h. So in that way, you can define the general one. Okay, nebula n fx will be 1 less than fx. So this is the thing differencing from the forward. Okay, so delta 1, we have delta n fx will be delta n minus 1 but if here x plus h comes, here delta n minus 1 fx comes. But here nebula n minus 1 same thing, but the fx minus h. So that's the differences. Okay, so you have to be careful on this. So that's all about the backward one. So let's do some exercises. Okay, I'll do one question. So I think it's your homework questions number 3 and 4. Okay. So let's, I think, yeah, we can do. Okay, so the third question says, construct the backward difference table. So here also they didn't give the, they also gave, but they used, I have used this one. Okay, according to this one only, they have calculated. So here, if they give the table, you don't need to spend time to, check. It should be correct, no? So if you have time, you can check it, okay? So let's make our backward difference table. Okay, so this is our x value, this is y values. So we have 10, 20, still we have the equal distance increments. So 30, 40, and 50. And the y values are 1.0000, 1.3010, again 1.4771, and 1.6021, 1.699, and 0, I think. Yeah. So can you help me to find out this one as well? Nebula y, what is nebula squared and nebula cube? I think we can go up to nebula 4y. So here, only thing is you have to be careful. You have to take this minus this. Okay, not this one, not like forward. You have to take this minus this. So what will be the answers? I mean, yeah. Backward one will be nebula y is equal to y minus yn minus 1. If it is n, okay. So here we are finding this one. So here you have to put as nebula of, so let's put our index as well. So I'll use any other color. Okay, let's say this is my 0, 1, 2, 3, 4. Okay. So here you have to tell this is for y1. So nebula y1, which is equal to y1 minus y0. So we don't have nebula y0 in any sense because there is nothing to, subtract, no. So so if you want to make the table, backward table, so you have to take this one as nebula y1. Okay. So this might